Good evening, everyone. My name is Baptiste, and with Emma, we are really happy to welcome you on our new show, Road to Space. We are live from Paris tonight to cover the launch of two very special and innovative satellites, one from EUTELSAT, the other from Embratel. This, of course, possible thanks to Arianespace, Ariane Group, the CNES, and the European Space Agency.
That's right, Baptiste, and we have a very exciting program lined up for you all tonight. In less than 30 minutes, the European launcher Ariane 5 will be taking off from the European Space Center in Kourou. We will be live from Ariane's main base of operations over there and be giving you privileged access inside the Jupiter control room for some exclusive behind-the-scene coverage.
And here in the Paris studio with Emma, we will receive and interview some space leading experts. We'll do our best to reply to all the questions we received via social networks. But before that, let's take a look at tonight's menu.
Tonight in Road to Space, we'll be live from Guiana Space Center with all the team. We are here, of course, to witness the launch of the Ariane 5 rocket, which will be sending two telecommunication satellites into orbit.
Star 1 D2, in 3 words: multi-mission, high performance, and connectivity.
Here, in the Paris studio, we'll be talking to space's top experts about the launch and showing you video reports on what the future holds for satellites.
Quantum is at heart the start of a revolution.
You will learn how a telecommunication satellite works, and we'll be giving you an exclusive look into the latest advances of the new European rocket Ariane 6.
Je vous propose de le découvrir de l'intérieur.
We'll also be answering all your questions on social networks and looking at the film Stowaway to find out if an intruder really could sneak his way aboard a rocket. But more than this, we hope that with Road to Space, you will spend a truly magical and unique night in our company, where Earth meets space and the present embraces the future. Welcome aboard Road to Space.
And so we're really happy to be with you tonight. And let's go directly to Kourou to meet our special first guest, Arianespace CEO Stéphane Israël. You're waiting for us. Hello, Stéphane. Welcome to Road to Space. Just one question. I see you're all on the deck getting ready for this upcoming flight, and it's a very special one. It's the Ariane 5, the European heavy launcher.
Yes, it is a very special launch tonight. It is the first launch of the year with Ariane 5, and we have on board two long-lasting partners of Arianespace. So with Star 1 D2 and with Quantum, we have really long-lasting partners tonight on board on Ariane 5.
Yeah, two special guests, two special passengers for you. And in a way, this launching is the climax of this campaign.
For sure, so we are now a few minutes before the launch, and you know, for having the liftoff at 6 o'clock p.m. Guyana time tonight, we need the satellite to be ready, we need the launcher to be ready, we need also the weather to be with us. We have now the final minutes up to the launch. We have a lot of very important operations to do before lifting off. So let's see how things are going to turn out, and we are confident for the liftoff.
We wish you good luck. We're sure everything is going to be perfect. Thank you very much, Stéphane. We'll come back to you a little bit later. And for all of you watching live, we will, of course, come back to Kourou regularly to inform you.
But for now, let's welcome Amandine Lux, who's just joined us into the studio. Good evening.
Good evening, Amandine.
Good evening, Emma. Good evening, Baptiste.
Welcome to Road to Space. You are Arianespace's Advanced Studies Director, and tonight you will be connected with Kourou, thanks to a little earpiece, and giving us regular updates throughout the program about the mission. But can you explain to us, firstly, what are the principal stages of the mission?
Yes, so we can have a look. We have a little animation, so we can have an overview of what we are going to witness tonight. So at H0, an important event, we will have the main stage engine ignition. And so after a few healthy checks, it will be followed by the ignition of the boosters. So I'm waiting.
Should be getting some images up on the screen.
Yeah, I'm waiting for the animation.
Okay.
We should see this animation. Well, normally it should appear on the...
Here it is.
Yeah, so that's it. So
you
will have the liftoff with the boosters ignition, and after a quick ascent phase, the launch vehicle will perform the pitch maneuver in order to get to the right direction. A few seconds later, after, when they are no longer needed, the booster are separated from the launch vehicle. And after that, we will separate the fairing, which protect the satellites, when it's no longer needed once the launch vehicle reaches out the atmosphere. So the main stage propel phase goes on till we reach the intermediate orbit. At this stage, we cut off the main stage engine. You have a distancing maneuver, and there will be the ignition of the upper stage engine after the separation of the main stage. So this second propel phase goes on till we reach the final orbit, the injection orbit, and tonight for our customers it will be the GTO orbit, the geo transfer orbit. The same as for the main stage, the engine we cut off when we reach the final orbit, and we enter then the ballistic phase, during which we will separate our customers. So first Star 1 D2, and after a few maneuvers of distancing, we will separate the dual launch structure because we have a second passenger. And so after the SILDA separation, this dual launch structure, we will separate our second passenger, EUTELSAT QUANTUM.
Okay, so those are all the points we have to follow, especially with you. And so you will be the one commenting with us all those key points happening during the launching. Well, thank you very much, Amandine. You stay with us. We'll come back to you shortly after. But before we are going to take a look at Star 1 D2, one of those two satellites that will be launched tonight. Star 1 D2 will improve access to high-quality entertainment and information services in Central and South America, and it will also connect undeserved population. Let's have a look at the report.
I would describe Star 1 D2 as powerful, hybrid, and 4-band satellites.
Multi-mission, high performance, and connectivity.
Star 1 D2 is the largest satellite ever launched for Embratel. It is the latest in a fleet of 12 satellites. Its role? To boost the coverage of satellites already placed into orbit for the operator. Claro is a leading telecommunications company, and Embratel is part of it.
Satellites will continue to be an important part of our infrastructure and business. We are part of the American Mobile Group, a leader in the telecommunications market in Latin America.
Star 1 D2 was built by Maxar at the manufacturing facility in Palo Alto in the United States. The satellite will be launched into geostationary orbit 36,000 kilometers above our heads.
Star 1 D2 is an important project for Maxar because of our partnership with Embratel in the geostationary communications market. We have been working on this satellite here at Maxar since the fall of 2017.
For over the past 36 years, Embratel and Arianespace have developed a strong and fruitful partnership. Since its creation in 1985, the Brazilian operator has entrusted the launch of all its satellites to Arianespace. And Star 1 D2 does not escape the rule. The CEO of Embratel explains to our journalists why the company always chooses an Ariane launcher.
We are working with the key international players to have the best combination of technology, cost, and performance.
Star 1 D2 will improve access to high-quality telecommunications and television services. It's intended to meet the needs of individual users, but also for businesses in South and Central America. The new satellite coverage will reach millions of people.
The most important technological challenges that we had to overcome to build this satellite were the fact that there were many diverse payload bands to make this satellite operational.
This hybrid satellite is composed of 4 different bands. The X band is for military use only. Star 1 C band has exceptional power. Thanks to this, the satellite will be able to offer television coverage to more than 20 million satellite dishes in Brazil. The KU band will accompany the country's transition to 5G, a government requirement. With the KA band, Star 1 D2 will significantly increase its mobile coverage capacity, particularly in the north of Brazil, which is one of the regions most affected by terrestrial connection problems. All of this will of course greatly benefit the population here. Each satellite beam will be able to connect 4,000 schools to the internet in the most remote areas. The development of the KA band in Brazil will also have an important impact on the agribusiness market.
To reach remote areas is our aim, to be the best option in all the market. With a great coverage of satellite, we will help transform businesses by bringing more possibilities for companies to reinvent themselves and to improve their service, in addition to providing people with more ways to communicate and be entertained.
Star 1D2, like the rest of the Star 1 fleet, will be controlled and monitored from the largest satellite control center in Brazil and Latin America, the Guaratiba Center. Created in 1983, it is located in the west side of Rio de Janeiro. But before taking off into space, the satellite had to go through another somewhat delicate journey. Its transport from Palo Alto to Kourou, in one of the largest cargo aircrafts in the world. Star 1D2 is now ready for its ride into space. Before this satellite takes off and finds its place amongst the stars, let's welcome our space expert, Raphaël Chevrier.
Welcome, Raphaël.
Welcome.
Hello.
You are a business developer in charge of innovation at Arianespace, and the question I want to ask you tonight is, today we can talk to whoever we want, anywhere in the world, but what about tomorrow? What does tomorrow hold?
Well, first of all, I'd like to remind that half of the population worldwide still lack of a reliable internet connection. And so satellites are really the perfect solution to come in addition to the terrestrial network to provide connectivity to remote area where it's just too expensive to put a cable there. I'm thinking of archipelagos, deserts, and mountains. And just to give you a recent example, we launched last year a Japanese satellite, BSAT-4B, who is right now providing TV broadcast in high definition for the Olympic Games that are happening right now. And I just wanted to remind that yesterday we had an engineer at Ariane Group, Astrid Guyard, who won the silver medal in fencing, and I want to congratulate her.
Wow.
Yeah, congratulations. What I understand is that it can change things for me as an individual, but what will it change for companies?
We can think of like very unlimited application there. If you have like a strong connectivity, you can apply it to moving targets like trains, boats, autonomous cars, planes, and etc. There are strong implications in telemedicine also, with tomorrow doctors being able to really take care of a person's health remotely in real time, and to assist, for example, a chirurgical act at distance. And also all applications related to Internet of Things, so that tomorrow you can actually monitor your house at distance remotely in real time, anywhere.
Well, thank you for all those information. You stay with us because we are going to focus now on the second satellite that will be into orbit tonight.
Yes, Baptiste, and this satellite is EUTELSAT QUANTUM. It was developed by ESA with the operator EUTELSAT and the satellite manufacturer Airbus. It is what you call a game-changing piece of technology. To understand how innovative it is, let's watch this short report. It took place a few days ago on Toulouse's Airbus Defence and Space facilities in France. It is here that the manufacturing teams were preparing to ship the satellite, EUTELSAT QUANTUM, before its long voyage to French Guiana, a rigorous operation in a sterilized room under controlled atmosphere. This 3.5-ton jewel of technology is the new benchmark in telecommunications satellites.
The EUTELSAT QUANTUM will be the first world commercial telecommunications satellite fully reconfigurable in orbit. Standard geostationary satellites are configured during construction over fixed coverage. With this new generation of satellite, you will be able to modify the coverage and to pinpoint a specific area and to define a route to follow a plane or a shipping vessel.
EUTELSAT QUANTUM is paving the way for a future generation of satellites and is a great example of international cooperation.
As you can see, the final assembly is done here in our facilities in Airbus Defence and Space in Toulouse. You can see the satellite behind me. And it's made of many components coming from Europe. The platform is coming from our subsidiaries, SSTL, for which we have developed this product for the low range of our satellites. The fully flexible, innovative payload has been designed and built in Airbus Defence and Space in Portsmouth, where this payload has been totally innovated. So the development of EUTELSAT Quantum Active Antenna is a new technology that is developed in Spain and that is paving the way, positioning Airbus as a leader for flexible payload.
What makes EUTELSAT Quantum so groundbreaking is its new multi-beam antenna. As we can see in this visual animation, its technological feat lies in its mobile aspect.
One of the main challenges and a great achievement for Airbus is the groundbreaking multi-beam active receive antenna named EUTELSAT+. New antenna technology is the key for fully digital payload. The quantum payload breakthrough is to change the coverage in real time from highly localized spot beams to regional and local footprints. As well, the flexible allocation of spectrum and power is a key differentiator.
Well, quantum is at heart the start of a revolution. It's the first commercial software-driven satellite with the ability to change both the frequency, the power, and the direction and shape of the beams that are being broadcast down to Earth.
In a few minutes, EUTELSAT Quantum will take off aboard Ariane 5 to its final destination, 36,000 kilometers above the Earth in geostationary orbit. From this position, the satellite will enable extensive coverage.
The satellite will be located at 48 degrees east and will cover a large region over the world from Europe to Middle East.
In addition, it will be the first satellite to be able to adjust to business requirements at any time within the space of about 10 minutes.
Traditionally, our customers order a satellite with a specified mission unchanged throughout the whole lifetime of the satellite. In the case of EUTELSAT Quantum, our customer is able to reconfigure by software control in order to adapt to changing market conditions.
Quantum is leading in the field for software-driven payloads on commercial spacecraft because it is the first to respond to a market demand for ultimate flexibility for customers.
With this new standard in flexibility, EUTELSAT Quantum will provide communications on the move as required by aeronautical, maritime and land transportation. It will also provide a rapid response to civil protection, natural disaster response and security missions, all using the latest encryption technologies.
In a few minutes, we'll be linking up to Kourou for the launch of the Ariane 5 rocket. But for the moment, Raphaël Chevrier, our space expert, is with us. Raphaël, let's talk a little bit more about EUTELSAT Quantum. And in the report we just watched, we talk about a geostationary position. What it is?
Yeah. Well, this is the position where the satellite is actually going. It's at 36,000 kilometers from the Earth. It is a very convenient orbit for telecommunication satellites because the movement of the satellites there are synchronized with the rotation of the Earth. It means that they can actually provide the same applications all day long to the same region because they are facing the same region. So
they're turning with the Earth at the same time.
Exactly.
Okay.
So yeah, so 24 hours a day they can deliver services there.
Okay, and also we've heard about the fact that the satellite will be placed at 48 degrees east.
Yeah.
Same question, why?
Well, because this location corresponds to the region that the satellite wants to actually deserve the application. So in this case, it corresponds to a broad region from Europe to the Middle East. And well, you've heard in the report that EUTELSAT Quantum is actually like a real concentrate of technology because this is a reconfigurable satellite. It means that it is as flexible as operating several satellites in orbit at a time, and it can quickly adapt to the market change geographically and in terms of frequency band.
Okay.
So it's a real game changer.
Yeah, it is opening a new way of doing business in space. Yeah.
Oh, thank you very much, Raphaël. And for all you watching us live, just stay with us because we'll be heading back to Kourou in a couple of minutes. But just before, let's watch what's coming next.
Tonight on Road to Space, we are live from Guiana Space Center with our teams over there. In a few minutes, we will witness the launch of 2 telecommunication satellites aboard the Ariane 5 rocket. In Paris studio, we will be talking to top space experts and discovering how a telecommunication satellite works. And of course, we will give you the latest news about the new European rocket Ariane 6.
Et je vous propose de le découvrir de l'intérieur.
Finally, we'll be answering all your questions on social media and asking our experts the question, is it really possible for a stowaway to sneak on board a rocket? You want the answer? Stay aboard Road to Space and enjoy the ride.
In less than 10 minutes, Ariane 5 will be lifting off from Kourou in French Guiana, but for the moment, let's welcome to the studio Mathieu Chez.
Welcome,
Good
Mathieu.
evening.
Thank you. Hi.
Mathieu, you've been working for Ariane Group for the last 18 years. You were part of the Ariane 6 development program, but we'll talk about that later. For the moment, we have a question for you and Raphael from our social networks, which should be coming up just behind me here. This one is from Daniel Fisher, a tweet. Do Arianespace and ESA have a defined opinion about the precise altitude where space begins? 100 kilometers or less or more?
Well, this question probably refers to the recent debate there was between two entrepreneurs that went to space. Richard Branson, who went to 80 kilometers of altitude, which is recognized as the space limit by NASA, and Jeff Bezos, who went to 100 kilometers of altitude, which is recognized as space limit by the International Aeronautical Federation. The reason for this debate is that the atmosphere is a continuous medium with no real limit. You can travel hundreds of kilometers and you will still find particles in space. So as a matter of fact, the atmosphere ends at 950 kilometers from the Earth. We don't really have this debate at Arianespace because we are launching satellites well above 100 kilometers of altitude, several hundred kilometers of altitude. And so we launch the satellites there, and it requires a huge amount of energy, right?
Yes, but okay, maybe you do not care about that, but when you're designing rockets, this is really a huge matter because, as you said, you're going through a continuous medium. You know exactly how you need to model it very precisely when you do simulations, because even though at 80 or 100 kilometers you don't have that many particles, still you are going through this medium at a very, very high speed. We're talking about 2 kilometers per second, and you know how many kilometers per hour it is, right?
Yeah.
Yeah, 7 to 8 thousand kilometers. Yeah, you did the conversion, of course. So from there, all the particles you will hit will create some aeroflux, and you need to be very aware of that, in particular, to determine the exact instant when you're going to separate the fairing, because you don't want the satellites that are protected by it to be hurt by these particles.
Okay.
So we have an end of question. Would this be of any operational importance for engineering, science, or legal reasons?
So for engineering, obviously, but even for the International Space Station, this is an issue because at 400 kilometers of altitude, they're not that far. There are still particles, and they're actually decaying slowly because they're hit by these particles. So they need to be reboosted from time to time.
Regarding science, this is why indeed.
Attention pour la séquence finale lanceur.
Well, sorry to interrupt you guys. Actually, we just heard the DDO.
Top à 0-7 minutes.
So it's 7 minutes away from the launching. Amandine, can you explain us who is this guy and what is this announcement?
Okay, so the DDO is the Range Operations Manager. And so tonight, as I am, he will be connected with the Telemetry Control Center. He will receive all the information so that we can follow what are the main milestones during this flight and that we are on track regarding the launch. So now we enter the synchronized sequence, so that means that we are good to go. We will get the launch vehicle ready for liftoff. We will perform the isolation of the ground vehicle, launch vehicle from the ground. If we are green to go, that means that if you remember, there was the panel behind you with all the greens. So that means that the space base is green. So space base ensures the means to track the launch vehicle and also the safety, the security. They monitor the safe weather conditions. We have, of course, the launch vehicle. And
the weather is important?
Weather is
even
really
to launch
important.
a rocket?
It's really important. It's really important at liftoff.
I ask you that because we can fly with planes on every weather.
Yeah,
so.
lightning are monitored because you don't want any kind of explosion at liftoff. And after that, the trajectory is computed following certain conditions for the forecast. And you don't want to have, for instance, high velocities for the winds, because otherwise you would have some risk towards population. And so the last green that you need, of course, is the one from our customers. So now, this is the final autonomous sequence. Everything will be transferred to give autonomy to the launch vehicle. It will be isolated from the ground. We will give the power to the launch vehicle. The launch vehicle will be the brain of itself, and it will be ready for the liftoff with the last operation, the preparation of the ignition of the main stage.
Okay, I'm sorry to interrupt you because I have the clock over there. We are 5 minutes away from the liftoff. Let's go to Kourou and let's go to the Jupiter control room to see what is happening over there. Hello, Cyrielle. Good to see you. You are our correspondent for Arianespace tonight, and you are going to be reporting for us from behind the scene in this famous Jupiter control room. Well, my question is simple. What is that room? I guess it's what we see behind you.
Hello, Baptiste, and welcome. Yes, as you've said, I am in the Jupiter Control Center, and more precisely in what we call the fishbowl. This is the place where we receive all the information regarding the spaceport and the Ariane 5 status. But let me introduce the teams. So just behind me in the front row and a little bit of the second one over there, we have the CNES launch specialists. They are in charge of coordinating and monitoring telemetry, weather data, telecommunication system of the Space Force, and so many other things. Now, right here on the second row, we have the satellite operators and manufacturers. They are here to monitor their spacecraft, and afterwards, they will confirm the acquisition of the signal, which then means that the satellite is fine. Next to them, in the middle, we have the CNES and Arianespace launch managers. That is where Didier is sitting. He's the one who gets to say the final countdown we are all craving for. Next to him, we have Arianespace mission director, the conductor of the mission, in charge of coordinating all the actors of the launch campaign. Now, all the way in the back, you have the authorities overseeing the launch. On the right, we have the one from the CNES, and on the left, the one from on the right, we have the one from ESA, and on the left, the one from the CNES. Now, let me take you to a very special place, Arianespace's den. So, this is where we have the area dedicated to the Arianespace project managers and the satellite program directors. They are here to make sure that everything is going smoothly. Now let's get to our final stop. Well, actually, you've already been here earlier today with Stéphane, who is now sitting right there. So this area is where our top management is overseeing the entire launch. And on the other side of this glass wall, you can see that tonight we have an audience. They are from the client's teams and from the spaceport. And we also have a few outside guests. As you can see, they are opening the door to actually let the public outside in order for them to actually be able to watch the show live from the terraces.
Well, thank you very much, Cyrielle, and we'll let those people concentrate because we are 1 minute and 28 seconds away from the launching, so from the liftoff. So now we're gonna watch the show because this is what we are here to enjoy the show. And
yeah,
cross fingers.
That's not exactly how we call it as engineers.
Attention,
yes.
une minute. Stop, I0, moins une minute.
So it's one minute away from the launching. We hear the DDO. This is the DDO speaking, announcing different steps.
Exciting.
And we will have the countdown within a few seconds. We are 45 seconds from the liftoff.
40 seconds away, wow.
I guess everybody over there is concentrated.
Look at Amandine.
Sitting next to me is really...
I live that so many times. You don't know all the things that can happen, so I'm really focused.
It's difficult for her because she has information on one side, talking to her. 15 seconds away.
Tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage EAP, décollage.
Maneuvers ongoing.
So impressive.
Remettre à bord nominaux.
Well, we have just seen Ariane 5 disappear towards space. Do stay with us, everyone, because what's going to happen next is as crucial as the next launch. This is, of course, the moment when the two satellites, Star 1D2 and EUTELSAT Quantum, separate from the launcher and are placed into orbit. But that's not all, is it, Baptiste?
Yeah, I guess it's not all. I was really watching at those impressive images. And to answer your question, I'm going to ask Amandine. So, Amandine, how many kilometers does Ariane 5 travel before the launching of the satellites?
So, in fact, Ariane 5 is not going to go to the GEO orbit, this orbit of interest. That would be quite a journey. So, we are going to the GTO orbit, so the Geo Transfer Orbit, which is an ellipse around the Earth, which lowest point is close to the Earth. And so, this is where the upper stage is going to get us. We will reach roughly an altitude of 650 kilometers. And this orbit, as an interest, the highest point is located at the same radius of the GEO orbit. And so that will be up to the customers once they are released into the GTO orbit to get to the GEO orbit and to do the final maneuvers to circularize the orbit and be in the GEO orbit.
I guess, and I hope everything is calculated and programmed. So what is the role of the team in Kourou right now?
So everything is pre-programmed on board, but you remember I talked about the onboard computers. So the launch vehicles knows exactly where it is located, what is its acceleration and velocity. Okay. And so it will reach the orbit by recomputing the orbit every time in order to get the maximum performance and the best accuracy. Right now, the main active people in Kourou, you don't see them, they are in the ground. We did have an important event. I have the confirmation that we have the EAP separation.
It's the booster separation?
Yeah, the booster separations. Yeah, boosters have been separated.
So that's at 2 minutes 20 is the time when the two boosters leave the rocket. Why is it specifically 2 minutes 20? Could it be earlier or later?
Yes, it can, because I was talking about the onboard computer. And so you trigger the separation of the boosters when you do no longer need them. So that means that they have done the job in showing most of the power that you need to escape from ground. And so by recomputing the trajectory, there is a point at which you know that they do no longer push because the acceleration is low. And so the onboard computer is going to trigger the separation of the boosters. And so roughly, usually it happens within a few seconds in comparison to the prediction.
And now we will be witnessing the next step, I guess, I hope.
I did have the confirmation, so now it's the separation of the fairing. So the fairing was there to protect the satellites from the acoustic in ground, because the liftoff creates a lot of noise, and from the atmosphere, as it was mentioned by Mathieu and Raphael. And so we separate the fairing. Same, the onboard computer, we compute everything, knowing exactly what is the velocity, what is the altitude. It can recompute the flux. And when we are under the threshold, the maximum flux that we authorize for the launch vehicle and for our customers, the onboard computer triggers the separation of the fairing.
Okay. I guess now, more or less, Ariane 5 is out of sight. How will we keep the link? How will Kourou keep the link with the rocket?
We will keep the link with the rocket thanks to a network of ground stations, which are in visibility with the launch vehicle. They receive what we call the telemetry of the launch vehicle. telemetry are the key flight measurements from the launch vehicle. And you have a team in Co, you were asking me the questions, which is located in the first station, the one in Galio. And they will receive all the telemetry of the launch vehicle. They will process it, analyze it, and make sure that it is coherent with what was the forecast. And they will give us and give me and give the DDO tonight all the main milestones.
Okay, so they're analyzing the data.
Exactly.
Okay.
And after that, the launch vehicle will be tracked by another network of stations. So it will be followed by Natal in Brazil. In the Atlantic Ocean, we will have Ascension.
We'll talk about that later, because I think we will
Kenya.
follow every step.
Yeah, we will.
We understand that the launcher is in full flight now. So what is its speed? What is its altitude? How fast is it going at the moment?
So right now we are at an altitude of roughly 160 kilometers, and the speed is above 3 kilometers per second. And
Okay,
so what
to explain the audience, you have all the numbers, all the data in front of you.
We do have the data. And so what is worth mentioning is that now the mass is only of 160 tons.
And before it was what, 775 tons?
Yeah, so
it's enormous.
Reason for which we separate these boosters, because simple rule in space, the lighter the better if you want to get faster.
Okay. Lighter, higher, faster. Okay, I understand. It makes me think of a song, Daft Punk song. But
Yeah,
that's
it's same for me.
Side subject. Mathieu, let me ask you a question. When we were preparing this show and we were talking about the VA254.
Yes.
So what is it? A code, secret code?
It's indeed a secret code. I cannot communicate on this, Baptiste. No, it's the numbering of the flight we're considering. For V for vol, A for Ariane, obviously, so Ariane flight 254. But what's interesting is that this counter started 41 years ago with the first flight of Ariane, which was Ariane 1 in 1979.
On the 24th of December.
December, yeah, because we launched on Christmas Eve when necessary. That was the birth of Ariane was on Christmas Eve.
Very nice. So for Christmas time, you watch the launching of the rocket.
No,
so it's kind of a good present.
Yeah, but I was not born.
I'm a bit surprised.
No, I was born a month later.
So now we are following the next steps, and we are about 7 minutes after the launching, and now you were talking about the bases on the ground on Earth, which are linked to the rocket. So now, who are we linked to? Where are we linked to? We will probably approach Natal.
We will approach the visibility of Natal, yes, indeed. And so that means that we are along the path away from the American coast.
Okay, so what is Natal?
Natal is a ground tracking station in Brazil.
In Brazil, yeah.
Yes.
And so now we're waiting the DDO announcement that would specify that Natal is linked to the rocket.
Yes. I didn't know.
Any news?
And so what's happening now? Is it really important being linked to Natal?
No, we still have under the visibility of Galio.
So it's not there
Okay,
yet.
so we don't have yet the announcement, but it doesn't mean no big issues yet?
No, because everything is still on track. Everything is as planned. It's nominal.
Okay, so that was the next step. And what is the step we are waiting for? Yeah.
We did have the confirmation of the acquisition by Natal. So now the next stage that we are waiting for is the cutoff of the main stage.
The EPC?
The EPC, yeah, the lower
you worked
stage.
a lot.
Yeah.
And so it will be cut off on guidance. So that means that we will have detected the intermediate orbit. I have the confirmation of the separation of the EPC, yes.
Yeah.
And so it will be followed by
EPC is upper stage?
the lower stage,
Lower
the main
stage.
stage.
Okay, lower
So,
stage.
and we do have the confirmation of the upper stage ignition. So it's always a critical moment for us because it's a cryogenic engine, and it's not a given for. It's always an intense moment because cryogenic ignition in space conditions. So now we enter the second propel phase with the upper stage that will get our customers to the final orbit, the GTO orbit.
Okay, well, thank you very much, Amandine. We keep on focusing on all those important informations.
Thank you, Amandine. Thank you so much for all that. Well, we are now less than 20 minutes away from the separation of the first satellite, and of course we'll be going live from the Jupiter control room in Kourou. But for the moment, let's now focus on today's passengers. 2 telecommunication satellites. How do they work? Well, the answer is in this short report, guys. To understand how a communication satellite works, you'll need to get the bigger picture. A satellite is made up of 2 parts. The service module or bus is the part that contains the equipment necessary for its operation. The other part is the communication module, called the payload. This is where the antennas and electronic equipment are located. Information is sent from a ground station, which then transmits this information to a satellite in the form of high-frequency signals. These signals arrive in the transponder, which receives and transmits the signal. They are then sent back to one or more other ground stations and relayed by antennas or cables to the end user. Looking up at the sky, we could notice that some satellites remain fixed and others move quickly. This is because they are not located in the same orbits. A satellite that remains fixed is in the GEO orbit, for geostationary. At about 36,000 kilometers in height, at the equator level, it revolves with the Earth. This is why it seems to be fixed in the sky, while it is moving at 3 kilometers per second. At this altitude, the satellite constantly covers a very large geographical area that never changes. To serve specific applications, geosatellites will need a hand. Some of them need a latency that is extremely low. Latency is the time needed for the signals to reach the satellite and return back on Earth. Less than 500 milliseconds on the one hand, less than 50 for low Earth orbit, LEO satellites. But as they are lower, between 400 and 2,000 kilometers of altitude, they move faster and cover a limited geographic area for a short time. They are then operated in constellations.
Well, Raphael, watching this report, we understood that the future of satellites is, in a way, in constellation. And we've been talking before the show, and I was talking to you about Jeff Bezos and Elon Musk. Elon Musk and Jeff Bezos. I heard they plan to send more than 45,000 satellites. My question is there enough room over there?
Well, just look at the sky and you can see that it's vast enough to host like many planes, for example. And space, it's much better because the more distance from the Earth, the more space and volume you have to be filled with satellites. It's not an issue in geostationary orbit because it's very far from the Earth. In LEO orbits...
L'acquisition de la télémesure par la station de Natal.
Yeah, sorry to interrupt you. Amandine, what does it mean, Natal?
Yeah, Natal, so that means that we have the
Perte de télémesure nominale, attendu.
Yeah, it was as it was planned, so we had the acquisition. Okay, so yes, there will be a gap of visibility, but that's completely planned, that's normal. Okay. And so during this phase, which is a quick one, all the data will be recorded on board. Okay. And so they will be transferred down to the next one station.
Acquisition de la télémesure par la station d'Ascension.
So Ascension will recover whatever has been downloaded, and it will be analyzed by the team.
Well, okay, everything is perfect. I'm sorry, we can go back to that question. Is there enough room over there?
Yeah, I was saying that the low Earth orbit is more like constellations, and I think that the main issue is to really set common rules in order to regulate the traffic, like we do it on the road and on the seas, in the air, of course. And the main challenge is to do it in a sustainable way. And yeah, in order to really avoid the satellites to collide with each other, that would generate many debris. And of course, that's not good in order to continue to do activities in space.
Okay. And just one quick question. I feel I have everything I need with my phone. What satellites and constellation can give me more?
This is because you live in Paris, a big city. And so, yeah, no, I mean, satellites are like a very good, even in big cities actually, satellites are good solutions to bring resilience to terrestrial networks. But it's also a matter of sovereignty for states, and this is why the European Commission is working on its own constellations of satellites in order to bring internet connectivity to European citizens.
Okay, well, thank you very much, Raphael. In less than 15 minutes, we'll go back to Operation Room in Kourou to watch the next stage of the mission. That will be the separation of the first satellites from Ariane 5.
But before this, let's now focus on something which we are all eager to hear more about. Of course, I'm referring to Ariane 6. Ariane's group next generation launcher. Let's look at this report and we'll talk about it afterwards, so sit back and enjoy. 4 kilometers from Ariane 5's launch pad, the future is well underway. Here at Ariane 6's launch zone, it's been a hive of activity, with its new impressive mobile gantry built on the launch pad and Ariane 6's assembly building. Work was carried out on 170 hectares of land surrounded by a tropical jungle, which now hosts the launch complex LE4. Thierry Vallée is the site manager for CNES.
Nous nous trouvons actuellement entre le bâtiment d'assemblage lanceur et la zone de lancement, sur la route qui relie donc les deux installations.
A giant mobile gantry has been built. It is 90 meters high and 50 meters wide and weighs in at 8,000 tons. It is heavier than the Eiffel Tower. The inside of this structure will be used to protect the workers in case of bad weather while they assemble the launcher.
Le portique d'Ariane 6 a cette particularité d'être mobile parce qu'il a besoin de pouvoir être déplacé de 140 mètres vers le nord pour dégager le lanceur quelques heures avant le décollage.
The infrastructure is already well underway, and since April, tests have been carried out in the spaceport, as you can see from these impressive images. Around the launch table, 60 valves must open in less than a second to let 30,000 litres of water gush through per second.
Le lanceur donc émet des gaz chauds à plus de 3000 degrés et génère des vibrations à 180 décibels, donc c'est à peu près 1 million de fois le bruit d'un marteau-piqueur. Et donc on imagine bien qu'il faut protéger les installations de toutes ces agressions lors du décollage. Les 900 mètres cubes d'eau qui sont nécessaires au déluge viennent d'un château d'eau qui conserve donc cette eau à plus de 80 mètres de haut.
After the launch, the water is pumped and sent to a water treatment plant.
Tous les paramètres naturels de l'eau vont être vérifiés et contrôlés. Et au bout de 2 semaines environ, donc l'eau pourra de nouveau être relâchée dans le milieu naturel.
In the meantime, the launcher is also getting itself ready. Ariane 6 has just passed its biggest technical challenge to date, the engine tests, which were all successfully completed.
Tous nos systèmes propulsifs ont terminé leurs essais de qualification et on a maintenant devant nous la démonstration que ces systèmes propulsifs fonctionnent dans leur environnement du système lanceur général. Ce sont les essais à feu à Lampolshausen et en Guyane. Les 2 grosses innovations, c'est sur les boosters à poudre avec une enveloppe composite et l'APU, ce système cryotechnique multirôle est unique au monde et on l'a inventé dans le courant du développement.
At the foot of the rocket, the P120C boosters, which also equip the Vega C launcher, can be integrated with either 2 or 4 boosters on Ariane 6. They provide thrust during the first 135 seconds of flight and ensure escape from the Earth's atmosphere. The second engine, the super powerful Vulcain 2.1, is the main stage engine and provides a thrust of 140 metric tons. Then comes the Turner Vinci, the upper stage engine. It's reignitable and enables improved precision on all types of missions and towards all orbits. The fourth motorized system, the auxiliary power unit, is the rocket's major asset. It enables payloads to be deployed into several orbits. This is crucial for satellite constellations.
Pour le lanceur lui-même, on a défini l'architecture du lanceur. On s'apprête à déposer la définition que l'on va qualifier pour aller en vol. Et à côté de ça, on a commencé à produire les étages. Un premier étage supérieur est sur son banc d'essai à Lampolshausen pour réaliser des essais à feu dans les semaines qui viennent. Et on réalise également le lanceur qui va partir en Guyane en septembre pour réaliser les essais combinés du sol et du bord.
In Kourou,
The European Space Agency, which funds and manages the entire Ariane 6 program, supervises the work carried out by CNES and Ariane Group.
Ici, nous nous trouvons devant le BAL, le bâtiment d'assemblage lanceur d'Ariane 6.
The agency is the architect of the project and is the main link between Europe and Guyana.
Dans ce bâtiment, nous intégrerons à l'horizontale, contrairement à ce qu'on faisait sur Ariane 5, les 2 étages, corps central d'Ariane 6.
For the moment, this is just a mock-up at the launch pad. Once the technical qualifications of the rocket elements are completed, Europe's spaceport will start its combined tests.
Pour ces essais combinés, nous aurons les premiers éléments maquettes, mais des vrais éléments lanceurs qui viendront des Mureaux, de Bram, etc. ici en Guyane, s'interfacer avec les éléments du sol développés par le CNES. L'objectif, à la fin de ces essais combinés, c'est l'autorisation de la première campagne de lancement Ariane 6.
In Ariane 6 schedule, this is the last step before its inaugural flight.
Welcome to the living room, Road to Space's living room.
Nominal,
Raphaël and
propulsion
Mathieu.
nominal.
Mathieu shares, you have been working for the Ariane Group and you are more specifically working for Ariane 6's development program since day one. Ariane 6's maiden launch is programmed for next year. Can you tell us a bit about what technical changes have been made to this Ariane as opposed to Ariane 5?
Well, I'm very happy about this report because you could really get an overview of everything that's new, and you could see the facilities we have and the new means, and with this means we'll be able to operate, manufacture, assemble the launcher in a cheaper and a very efficient way. This is a really big change. Also, the fact that you could play with a number of boosters, either with 2 or 4 boosters, means that with Ariane 6 you actually have 2 launchers for the price of 1. And finally, the big game changer to me is the upper stage. The upper stage, cryotechnic upper stage with Vinci and APU engines that we can reignite in orbit. And from there, it opens many perspectives in terms of missions.
Yeah, I agree with you. We can do like many type of missions to any orbit. It's also important because you can actually do rideshare mission. You can accommodate as many satellites as you can under the fairing and to separate them in different locations in space. And of course, this is very important to deploy these constellations of satellites.
And to the moon?
Yeah, as a matter of fact, we are preparing the first European mission to the moon with Ariane 6. It's going to happen during this decade. And we are also preparing a mission to Mars. It's going to happen in 2026 with Ariane 6. We will send a space probe to Mars. We will catch the Mars samples that was collected by Perseverance, and we will bring back to Earth in 2031. So this is very, very exciting perspectives.
Thank you so much, you two. We're now going to go back to Baptiste, who's with the representative from the European Space Agency. It's back to you, Baptiste.
Yeah, thank you, Emma. Thank you, Emma. I'm sorry. Good evening, Daniel Neuschwander. Welcome to Road to Space. You've worked all your career in space industry, and you are today the Space Agency's Director of Space Transportation. In the last report we saw, the Next Tech report, we saw that Ariane 6 is now turning into reality. Can you tell us what was ESA's role in the development of the launcher?
Yes, good evening to all of you. And ESA's role in the development of Ariane 6 had basically 2 main functions. Number 1, we were the development procuring entity, and second, we were the launch system architect, as you just said it in the film. This means that we define the high-level requirements, we adapt the institutional needs for the future of this launcher, and we accept the deliverables, which is the rocket on the one side, provided under primeship of Ariane Group, and on the other side of the launch base, provided by CNES. We bring it together at the occasion of the combined test, where we manage them through the definition of this combined test, where it has to have a perfect synchronization of these 2 elements, and we verify that this happens before we go to liftoff.
Well, thank you very much, Daniel. Next to you, we have Marie-Anne-Claire, the director of the Guiana Space Center. Marie-Anne-Claire, do you hear me? Yeah, nice to see you.
Yes, good evening.
We saw also in the report those new buildings have been built for the upcoming launcher. How many people were involved in such a huge work and huge construction?
Trajectoire nominale.
We started the construction for the new launcher Ariane 6 in 2019, so it is 3,000 people which are working on the base to adapt it, but not at full time, and we have a peak in 2018 with 600 people, and today we are around 200 people which are working still on the ELR4 in order to start and to prepare the combined test as explained by Daniel before.
Well, thank you very much, Daniel. Thank you very much, Marie-Anne-Claire. We'll come back to Kourou a little bit later. Now we go back to a live sequence because we are approaching a critical or important sequence, Amandine. In a couple of seconds, the DDO would normally confirm the switching of the engine on the upper floor. This is the information you're waiting for.
Yes, we are waiting for the shutdown of the upper stage engine. So that means that we would have reached the final injection orbit, the TTO orbit.
So it's a critical and really important moment.
It's an important moment, so that means that we have finished the propelled phase.
What happening?
Okay, so we had the confirmations that, so the upper engine has been cut off, and so now we are in orbit.
Okay. So as we say, so far, so good. Thank you very much, Amandine. In a minute, we'll be focusing on our social networks and answering your question. Just before, let's have a look at what's coming next.
Tonight, in Road to Space, we've just witnessed the launch of Ariane 5 and 2 telecommunication satellites. Shortly, we'll be answering all your questions from social networks and taking a look at a science fiction film, Stow Away. We will ask our experts, is it really possible for an intruder to get aboard a rocket?
How long was I out? Please, I gotta get back. We're not going back. What do you mean we're not going back? This is a 2-year mission.
Fact or fiction, stay with us for the next part of Road to Space.
Raphael and Mathieu, well, we're back and we have another question for both of you from our social networks. As you know, our time is limited because in less than 4 minutes we'll be going back to Kourou, where all the team is waiting for the next step of the mission, the first separation. But I've got another little tweet from Arthur du Abmir, who's asking us about the Kessler syndrome. Now, what is the Kessler syndrome?
Well, this is a theoretical scenario according to which the number of space debris in low Earth orbit reach a point where it creates like a chain reaction, leading to so many debris in orbit that we would actually not be able to use space anymore. But thankfully, in Europe, we have a French space law, which is ruling the way that we are performing our launch missions in a way that we are observing the best practice in order to really make launch services in a most sustainable approach.
Yes, indeed. So I just told you about the fact that you can reignite the upper stage of Ariane 6. We'll be able to do that, which means that at the end of the mission, once you've deployed the satellites, you'll be able to reignite the Vinci engine or the APU to perform a deorbitation, which means that you remove the upper stage from its orbit. So it means basically that at the end of the mission, we clean behind us.
Yeah, the Kessler syndrome, the Kessler effect you're talking about reminds me of the first sequence we had in the movie Gravity. Is it the same thing?
This is exactly the type of catastrophic event.
You're more studying movies than...
We are not there yet, thanks to Thomas Pesquet.
Well, thank you very much. Thank you both for all this information. Thank you very much. We have more questions for you, and we will try to answer all of them by the end of the program. But now it's time for us to focus on Embratel satellite Star 1 G2, which is just about to separate from Ariane 5. So we're waiting for this moment. And Amandine, you will tell us?
Yeah, I will tell you. For the moment, we are doing all the maneuvers necessary before the separation of the satellite. It's what we call the space ballet. So you want to get to the right attitude, the one desired by the customers, the right spin. And I did have the confirmation of Star 1 D2.
Star 1 D2.
Well, So far, so good. Let's go back right now to Kourou, where normally Cyrielle should be linked with us. Cyrielle, are you waiting? Do you hear us, Cyrielle? Well, we can see all the faces in the Jupiter room. Everybody is really concentrated. Ah, Cyrielle, it's good to see you. What's the atmosphere
Yes, welcome
there?
back, Baptiste. Well, actually, as you can see, still tensed. We just got the confirmation of the separation for Star 1D2, but let's remember that we still have a second passenger on board, and the mission is not over just yet. So that's why you see that people are still working, concentrated, and we're waiting for the next update.
Well, thank you very much. We could say that half of the job is done, main part of it, but we still have a big issue. And this issue, Amandine, we are going to talk about this first separation with you, Raphael. But just before, Amandine, can you tell us more about SILDA?
Okay, the SILDA is the black cone that you can see on the animation. So that's what we call the dual launch structure, and that allows us to perform the dual launch configuration. And in fact, what you want to do is to make the most of all the performance available. I did have the confirmation of the separation of the SILDA. So the SILDA is the structure that allows you to embark two satellites that want to go to the same direction. Okay. And in fact, if we want to talk about innovation, that's somehow a precursor of the next right-share missions.
EUTELSAT QUANTUM.
And now we will perform the next maneuvers in order to get to the right attitude and orientation for EUTELSAT QUANTUM.
Thank you, Amandine. If I can come back to you, Raphael, and talk about the first separation that just happened. For the operator, Embratel, this must be such a relief for all the teams over there. They were under such a lot of pressure. What do you think?
Yeah, of course. I mean, like Cyrielle and Amandine said, Ariane is actually designed to do dual launch, so we are separating two satellites in orbit. Baptiste said that half of the job was done. Actually, we have three separations: the first satellites, the SILDA, and the lower satellites. It means that I can let you imagine if the SILDA is not rightly separated, what's going to happen when we try to separate the last satellite. So, of course, everybody is still focused on the rest of the mission.
Yeah, actually, yeah, we were focusing on the satellites, but yeah, there's the SILDA is, I mean, if it's still there, I guess you can't separate from the second satellite.
You have some problems, yes.
Okay.
I can feel
well, before we focus on the separation of the EUTELSAT Quantum, the second satellite, we are going to take you on a journey, on a voyage. We are going to watch the trailer of the science fiction film named Stowaway, and then we are going to try to answer a question called a passager clandestin, an intruder, an illegal intruder gets into a rocket. Let's watch the trailer of the movie.
Hi, Michael. I'm Marina Barnett, the commander of the ship. Do you remember what happened on the pad?
I'm a launch support engineer, ma'am. How long was I out?
We took off about 12 hours ago.
12 hours. I need to get back to my sister, please. My sister, she's alone. Please, I gotta get back.
We're not going back.
What do you mean we're not going back? This is a 2-year mission.
2 years is a long time to be away, but this is the opportunity of a lifetime.
That was, well, welcome you both back to the fact-checking segment from Roads to Space Living Room. I have with me, I'm just going through the trailer, and for all of those of you who haven't seen it or haven't seen the film, maybe I should put you back in the picture of the summary. It's the story of a 3-person crew on a 2-year mission to Mars and the dilemma they face when an unplanned 4th passenger suddenly arrives on board, what we call the stowaway. So my first question, obviously, to you both is this a plausible scenario?
I really hope not. No, if it happens, I really would advise the launch service provider to rethink its processes, because it's all about processes, right?
Yeah, if you think about when we manufacture the launcher, everything is checked, because one of the risks that we fear is what we call foreign object damage. Okay, so that we have you forgot a screwdriver, a tool, anything, and it damages the rocket during the launch. So everything's monitored.
Yeah, and every tool is labeled, and you have a specific team who is taking care of making sure that nothing is left inside the launch vehicle.
So everything inside, okay, but what about outside? I mean, we are in Kourou, for God's sake, it's a tropical jungle out there. What about mosquitoes flying around? What about animals?
Okay, yeah, I can confirm, Kourou is wild. Yeah, when you're there, when you're dealing with huge integration holes, what you fear is that some birds, for instance, get inside the buildings.
This is why we had to hire also an animal specialist in animals' behavior, who's in charge of, when we open the door, to place traps, to actually make diversions with flashlights, etc., in order to prevent animals to come in.
What about dust particles getting into the top of the satellite?
Yeah, even a speck of dust is an issue for us. So that's why the air is filtered around the satellites and clearly monitored.
Yeah, and for scientific payloads, it's even worse, like the James Webb Space Telescope that we will launch at the end of this year.
I think we have some images here of the cleanliness curtain.
You know, a speck of dust would really damage the mission and make this telescope blind. You see that here they are using UV lamp in order to really detect the dirt there. If, for example, if you're proud of the cleanliness of your bathroom, just light it up with a UV lamp, and I promise that you will never want to shower again there.
Why would you do that?
Thank you so much, guys. Well, now I know, I'm reassured that there is no way an intruder can get into an Ariane 5 rocket. Well, I think we're going to go over now to Kourou and go over to Baptiste, who will be talking about the separation of the EUTELSAT Quantum. Let's go over to him now.
Yes, Emma, in less than 10 seconds, more or less 10 seconds, EUTELSAT Quantum satellite should be released from Ariane 5 launcher. So that's really a crucial point. We're waiting, and we should see the people happy and clapping if everything is turning good, and that should be on the predicted time, 10 seconds away.
So we had the acquisition of the white attitude. Okay.
So here it's quiet, but lots of things happening over there.
We had this, yes, we had the separation of EUTELSAT Quantum. So that's the end of the mission for the launch vehicle.
Okay, so we hear people clapping. I see your face. I see your face, Raphaël, and Mathieu also. So I guess this is, in a way, the end of the mission. Let's go back immediately to Kourou to see the atmosphere over there. Yeah, you can see the team cheering up, clapping. And now we should be linked with Stéphane Israël. Stéphane Israël, are you there? I remember Stéphane Israël is the CEO.
Sure, I am here with you.
Okay, yeah. You still have your mask, but I can figure out a huge smile. Yeah, yeah.
Nice.
So you're happy. Good news. And good customers,
I'm very happy,
customers.
but I am happy for my customers. Yes, for sure. It's very important for our customers.
Well, it's okay. This is why we are launching satellite, because we have a little delay between Stéphane and me. And well, you were talking about your happy customers. I guess it's really important for you.
Yes, it's very important for Arianespace because it was the first Ariane 5 of the year, and it had to be a success, and tonight it's a great success. It's very important for us to pay the tribute to all the contributors of this success. We have our prime Ariane group. We have here with us CNES, which is our daily partner in CSG. We have ESA. It is a success of the whole European team, for sure, Arianespace as well. And for our customers, Brazilian customer Embratel, French customer EUTELSAT, very innovative satellite, Maxar, American manufacturer, Airbus Defence and Space, European manufacturer. Tonight, it's a victory for all of them, and I really want to thank them for their trust to Arianespace.
And it's a great start for what you call the Ariane season, because it's just the first launching.
Yes, it is the first of the Ariane season, and you know that now we have two very important Ariane 5 which are about to be launched. One will be for SES and the French DGA, and the other one for James Webb Telescope. It will be the climax of the year. And we have also, during this summer, a very busy summer, we will have Vega for Pléiades Neo for Airbus on August the 16th, and then a Soyuz from Baikonur on August the 19th for OneWeb. So it is also the beginning of a busy summer for all our teams.
Well, thank you very much. Good luck for a huge job you have during the summer, and we'll be watching, definitely, we'll be watching the next launching. Thank you very much, Stéphane.
Meanwhile, let's take a moment to answer one last time the question sent by our audience, and it sure is a headline topic we've kept for you. Let's take a look with our first tweet from Astro Hayden, who I believe is a guy. Greetings, Arianespace. I'm very excited for the future with advancement of technology capabilities. How far are we away to one day launching humans on an Ariane rocket?
Yeah. That's a question for Ariane.
Okay, but I can confirm it's a boy, actually. We know well.
It's a boy?
Yeah, during lockdown, he made very good use of his time because with his parents, he built an Ariane 6 model, which is very, very nice.
So he's probably one. He will be maybe sitting on your chair,
Yeah, and maybe he'll build a rocket that bring human to space. And I'll tell you why, because I think we have all the techno bricks to go to space. What do you need? You need to have a reliable launcher with high performance. That's what you'll get with Ariane 6, because we'll be able to launch more than 4 astronauts to space with the performance we'll get. You need to be able to re-enter from space. This is something that has been demonstrated with the IXV program. It will be done with the Space Rider, something that we master. And then the final brick would be, can you do a capsule? Can you do a spaceship that goes to space? We did that 5 times, launched by Ariane 5 with the automated transfer vehicle. But we are still doing things on that topic with Orion, for instance.
Yeah, we can mention that ESA is implied in the Orion module, which will bring human back to the moon, actually.
Whoa.
Yeah, so I actually really agree with you, Mathieu, that Europe has everything needed to do this. The experience, the technology, and the motivation also.
Oh, yeah.
And as a matter of fact, also in a more commercial perspective, this market is getting stronger and stronger. Today, with astronauts going more often into the ISS, that is where our European hero, Thomas Pesquet, is actually
he's probably watching our live now.
I hope he is watching us, yes. Hello, Thomas. And tomorrow, many more astronauts going to the moon. And so, yes, just...
Let me ask you a stupid question. Why should humans go back on the moon?
For many, many reasons. First of all, because I was not born when it happened before. Okay? So I need to do this live. And the moon is also very scientific, lots of scientific interest. Because we went there, but we didn't. We went to a very few locations on the moon, and we brought back samples that are very limited, and the moon can really bring us knowledge on how the Earth was formed. But also the moon has resources on the surface. You can, for example, transform the regoliths, which is the dust that is covering the surface of the moon, into water or oxygen. So it really gives you the conditions to really dream of a sustainable presence of a human on the moon. And you can also dream of transforming it into fuel in order to fuel rockets that would lift off from the moon and go deeper in space, for example, Mars, but even deeper than that. So lots of very exciting perspectives on the moon.
That's a dreamer.
That's a dream.
We had another question on social media.
Yeah, we had one from Roman, Batman he's called. Is the Ariane 5 officially certified to fly humans?
Yeah, I think it refers to the fact that Ariane 5 was also initially thought to be flying Hermes, which was the European spaceship somehow program, but it didn't happen. But there's a good point about this is that the high reliability you have with Ariane 5 is actually in the DNA of the rocket because of this ambition. So it has not been certified per se for human spaceflight, but still we somehow inherit from it.
Okay, can we dream big and imagine, for example, a space station like the ISS around the moon?
This is not a dream. It's actually happening.
Yeah.
Like, you know the ISS, the International Space Station, is going to come to an end. And the states that are investing in the ISS are thinking and building right now a lunar gateway, which is like an international space station around the moon, in order to make this sustainable presence of a human astronauts around the moon a reality. And Europe is actively participating to this, to some module of these space stations. So yes, you need to dream much bigger.
But you think bigger. Well, we'll have a lot of topics to discuss on the next shows because it's really interesting. Sure. That's a key. That's a question that is, interesting everybody. Yeah. Thank you very much, both of you, for all this information. And we are now going back to Kourou to see how the teams are going and to meet some really happy customers, I guess. Hello, Cyrielle. It looks you've changed place.
Yes, actually, I'm a little closer to the main screen we have in the fishbowl.
Well, okay, so close to the main stage. Well, Cyrielle, it looks like it is time for us to meet our next special guest. We have Pascal Omzi, CTO of EUTELSAT, Elodie Viau, Director of Telecommunications and Integrated Applications at ESA, and we have also Christophe Dallest, EUTELSAT Quantum Program Manager at Airbus Defence and Space. It's hard to say. Can you ask them some questions for us, please?
Yes, of course, Baptiste. So, Pascal, you just saw your satellite separate from Ariane 5. How do you feel?
Well, I have to say that I feel absolutely incredible. So we have received the telemetry. I can even say that I have breathed the quantum sigh of relief, to be honest. It has been a long journey with this satellite, which has met some challenges. But we're extremely happy to have witnessed this beautiful launch today.
Well, thank you. EUTELSAT Quantum is what we can call a game changer. What is it going to change and how important is it for your company?
So EUTELSAT Quantum is indeed a game changer. It's a satellite of a new type, a flexible satellite, which will be able to be controlled in orbit from the ground through software. So that is a great advantage for our client. So coverage and power, spectrum and capacity are going to be reconfigurable at any time. So this makes an extremely good use of resources. So it opens also the door for new applications like data, government and maritime applications.
Well, thank you, Pascal. So, Elodie, the satellite was developed under a public-private partnership, right?
Exactly. So Quantum Satellite is a satellite that has been developed on a private partnership, public partnership, with the operator EUTELSAT and this European Space Agency. So these public-private partnerships allow us to share the risk with the operator and boost the innovation that EUTELSAT Quantum Satellite is carrying on board.
Okay, so it is really important for the European landscape, right?
Yes, so many countries, 6 countries got together to support all the innovation developed on board of EUTELSAT Quantum. So UK, the Netherlands, Spain and Italy, as well as Norway and Canada, boost their industry and supporting the commercial private actors. In addition to that, we have now EUTELSAT Quantum that is leading the way of getting towards software-defined satellites. And there is now the next generation of satellites that they are under development with a lot of innovation between the European Space Agency and all the commercial actors.
Wow, that sounds incredible. Thank you, Elodie. So now, Christophe, it has been a long journey for your team. They had to develop brand new technologies for the satellite. How is it to be part of such an incredible journey?
Well, it was a very exciting project. I would like first to thank the Airbus teams in the UK, in France, in Spain, in Italy, in the Netherlands, and as well as the SSTL team for their hard work and dedication throughout the program. The program has been made possible by the very strong support from ESA through this public-private partnership, and as well thanks to the very constant will of EUTELSAT to go throughout the program. So it has been a very important experience. Now we have received the spacecraft telemetry. We know that we have a bit of critical operation to perform in order to complete the job and to go through the early orbit phase and through the in-orbit acceptance. But I'm sure that the Airbus team, along with all the partners, will carry on to bring the customer satisfaction at the high level.
Well, thank you, Christophe. Now, Pascal, one last word for your team and partners.
Well, I would like to thank, obviously, our supplier and partner, Airbus, the teams in the UK and in France who have been working on this satellite for quite some time. I would like also to thank the European Space Agency and the UK Space Agency for having contributed to the funding of the development and construction of the satellite. Of course, our long historical partner, Arianespace, who offered us a fantastic launch today. I would like also to thank our co-passenger, Star 1D2, with the team of Marcello, who shared the ride with us today. And of course, the team of EUTELSAT, those who are here with me and those who are also back in Europe, who have been working on this satellite. Now the time has come to go and sell. I have a personal note for Philippe Oliva, my colleague from EUTELSAT, who is the Chief Commercial Officer. Philippe, now you have the satellite, you can go and sell, and I wish EUTELSAT Quantum a really long life and a commercial success. Thank you very much.
Well, thank you, Pascal. We shared you too.
And thank you to you all over there. Thank you, Cyril. Cyril, it looks like it's time now to meet with another special guest. You have a representative with you from Embratel, is that right?
Yes, I'm with Marcello Lavrado, the operator's satellite mission. So, Marcello, what is it like for Embratel to have another satellite successfully launched?
Good evening. You are very proud about the successful launch for Star 1D2. A very special moment for us. We just launched a satellite, the biggest satellite that we have a very important role in Brazil and Latin America. I speak on behalf of our team, and we are very happy with the launch. And I would like to thank you, everyone who participated in this important project when Embratel, claro, especially Ariane and Maxar teams. I'm very happy with this launch.
Well, thank you, Marcello. So, how important is Star 1D2 for Embratel and for the market in general?
This satellite is very important to us, and in the Central and the South America, especially in Brazil, in places where the terrestrial infrastructure does not reach. The satellite has a very important role to connect the people and the business. And the Embratel segment with Star 1D2. And I'm very happy with this launch and the long life for our satellite D2.
Well, thanks again, Marcello. I know you still have work to do, so I'll let you go ahead. And well, back to you.
Thank you very much.
The mission is accomplished. How relieved do you feel? I'm already jittery.
I'm relieved as you are, as we all are. So, to be honest, I'm entering the passivation phase, just like the upper stage is doing right now.
I still focus personally.
Still, I'm focused. Thank you, Amandine. Thank you, Mathieu. Thank you, Raphael. Thank you, Baptiste. And congratulations to everyone at Arianespace, Ariane Group, European Space Agency, and the CNES for making this launch happen.
Road to space, I'm sorry. We'll be back for the next launch with more exclusive and exciting contents. Good night, everyone. And if you look at the stars in the coming days, remember, we are building the future up there.